Welcome back to our class on software engineering. We're now in the second lecture of this last major section on software management. And we went over the general project management overview lecture last time. And this time what we're going to do is we're going to get into more details about project planning. And so project planning, the things that we'll be talking about are the software pricing, plan-driven development, project scheduling, agile planning, estimation techniques, and a cost modeling example with anyway, when we get to that, you'll get a chance to see more about it. So these are a lot of the programmatic kind of things that you need to be doing to keeping a project on track. So project planning involves breaking down the work into parts and assigning these to project team members, anticipate problems that might arise, and prepare tentative solutions to those problems. The project plan, which is created at the start of a project, is used to communicate how the work will be done to the project team and customers, and to help assess progress on the project. The stages, you have the proposal stage, the startup phase, and periodically through the project. In the proposal stage, this is where you are bidding for a contract development and providing a software system estimate. During the project startup, this is when you have to plan who will work on the project, how the project will be broken down into increments, how resources will be allocated across the company, etc. And then periodic reviews, this is where you modify your plan in light of the experience gain information from monitoring the progress of the work. For proposal planning, planning may be necessary with only outlined software requirements. The aim of the planning at this stage is to provide information that will be used in setting a price for the system to customers. Project pricing involves estimating how much the software will cost to develop, taking factors such as staff costs, hardware costs, software costs, etc. into account. For the project startup phase, at this stage, you know more about the system requirements, but not have design or implementation information. So the goal is to create a plan with enough detail to make decisions about the project budget and staffing. Startup plan should also define project monitoring mechanisms, and a startup plan is still needed for agile development to allow resources to be allocated to the project. For development planning, the project should be regularly amended as the project progresses and you know more about the software and its development. The project schedule, cost estimates, and the risk have to be regularly revised. What about the pricing? Software pricing estimates are made to discover the cost to the developer. Producing a software system, there is not a simple relationship between the development costs and the price charged to a customer. Broad organizational, economic, political, and business considerations influence the price charged. Here are some factors that affect software pricing: contractual items, cost estimation uncertainty, and financial health. So those are things that you need to be aware of. In addition to market opportunity and requirements volatility, developing organizations may quote a low price because they wish to move into the market. So that might be an opportunity. Requirements volatility, if there's a lot of volatility, that's going to definitely create some more uncertainty, and that's going to impact the price. So for underpricing as a strategy, a company may underprice in order to gain a contract that allows them to maintain staff for future opportunities, enter into a market or something like that. Increased pricing may be when a buyer wishes a fixed price contract, so the seller increases the price to allow for unexpected risk. Pricing to win, the software is priced according to what the software developer believes the buyer is willing to pay. If this is less than the development cost, the software functionality may be reduced accordingly with a view to extra functionality being added on at a later release. Additional costs may be added as the requirements change, and these may be priced at a higher level to make up the shortfall in the original price. What about plan-driven development? Plan-driven or plan phase development is an approach to software engineering where the development process is planned in detail. Project plan is created that records the work to be done, who will do it, and the development schedule and the work products. Managers use a plan to support a project decision-making and as a way of measuring progress. What are the pros and cons of a plan-driven development? The arguments in favor of a plan-driven approach are that early planning allows organizational issues to be closely taken into account and that potential problems and dependencies are discovered before the project starts rather than once the project is underway. The principal argument against plan-driven development is that many early decisions have to be revised because of changes to the environment in which the software is to be developed and used. For project plans, plan-driven development environment, a project plan sets out the resources available to the project, the work breakdown, and the schedule for carrying out the work. The plan sections would be introduction, plan, project organization, risk analysis, hardware and software resources, a work breakdown, a project schedule, and monitoring and reporting mechanisms. So here is the project plan supplements, things that you would have. You would plan for configuration management plans, deployment plans, maintenance plans, quality plans, and validation plan. For the planning process, the project planning is an iterative process that starts when you create an initial plan during the project startup phase. Plan changes are inevitable as more information about the system becomes available and changing business goals, which leads to change in project plans. Here is an illustration of the planning project process. And so you identify the constraints, risks, milestones, and deliveries that feeds into developing a schedule. Having a system project planner would be involved. And then you decide if you're going to do the work or monitor progress against the plan and also monitor against the plan. And so you basically work through your whole process, hopefully getting to having a finished plan. For planning assumptions, you should plan realistic rather than optimistic assumptions when you are defining your project plan. Problems of some description always arise during a project, and these lead to project delays. Your initial assumptions and scheduling should therefore take unexpected problems into account. You should include contingency in your plan so that if things go wrong, then your delivery schedule is not seriously disrupted. In terms of risk mitigation, if there are serious problems with the development work, they are likely to lead to significant delays. You need to initiate risk mitigation action to reduce the risk of a project failure. In conjunction with these actions, you also have to replan the project. This may involve renegotiating the project constraints and deliveries with the customer. A new schedule of when work should be completed also has to be established and agreed with the customer. For project scheduling is a process deciding how the work in a project will be organized in separate tasks and when and how these tasks will be executed. You estimate the calendar time needed to complete each task, the effort required, and who will work on the tasks that have been identified. You also have to estimate the resources needed to complete each task, such as the disk space required on a server, the time required on specialized hardware, such as a simulator, and what the travel budget would be. Project scheduling activities, there's a split project into tasks and estimate time and resources required at each task. There is the organization task occurring to make optimal use of the workforce and minimizing task dependencies to avoid delays caused by one task waiting for another to complete. And finally, dependent on project manager intuition experience. And so these are all the things that you would be considering. So you identify the activities, identify the dependencies, estimate the resources for each, allocate people to the activities, and create the project chart. And this is an iterative process. And eventually you have a bar chart describing the project schedule. For scheduling problem, estimating the difficulty of problems and hence the cost of developing a solution is hard. Productivity is not proportional to the number of people working on a task. Adding people to a late project makes it later because of communication overheads. The unexpected always happens, and always allowing contingency and planning is an important thing. For schedule presentations, graphical notations are normally used to illustrate the project schedules. These shows a project breakdown into tasks. Tasks should not be too small, and they should take on the order of, say, like a week or two. It can be calendar-based, where there's bar charts that show the most common use represented for project schedules, and there can also be activity networks showing dependencies. For project activities or tasks are based on basic planning elements. Each activity has a duration, an effort estimation, a deadline, and a defined endpoint. So those are all important to be sure to have. Milestones and deliverables. Milestones are points in a schedule against which you assess progress, for example, to hand over the system for testing. Deliverables are work products that are delivered to the customer, for example, requirement document for the system. Here are some examples of task durations and dependencies. This is notional, but you can get an idea of what it might be like. Here is a bar chart giving you a schedule for each one of those tests, those activities that are defined in this previous chart, and you can see how that would work. For staff allocations, this is where you start to specify individuals that are working on what task and over what weeks. And so this is a staff-loaded schedule. For Agile planning, it's a slightly different approach, but Agile methods of software development are iterative approach where the software is developed and delivered to customers in increments. Unlike plan-driven approach, the functionality of these increments is not planned in advance, but is decided during the development. The customer's priorities and requirements change, so it makes sense to have a flexible plan that can accommodate these changes. For the planning stages, there's a release planning and iterative planning. So the release planning is where you look ahead for several months and decide on features that should be included in the release of a system. For the iteration planning, this has a shorter term outlook and focuses on the next increment of a system, say 2 to 4 weeks. For approaches to Agile planning, you could plan in a Scrum. This was covered in chapter 3, so you could review that. Could be based on managing a project backlog with daily reviews of progress and problems, and also going to have a planning game. Think in terms of extreme programming and things like that. For story-based planning, the planning game is based on user stories that reflect the features that should be included. The project team reads and discusses the stories and rank them in order. Stories are assigned, quote, effort points, reflecting the size and difficulty. The number of effort points implemented per day is measured, giving an estimate of the team's, quote, velocity. And this allows the total effort required to implement the system to be estimated. Here is an illustration of the planning game. You go from story identification, initial estimation, getting into release planning, and then breaking that down into iteration planning, task planning, and having an iterative loop as you're looking at those together. For release and iteration planning, release planning involves selecting and refining the stories that will reflect the features to be implemented in a release of a system. Stories to be implemented in each iteration are chosen with a number of stories reflecting the time to deliver an iteration. The team's velocity is used to guide the choice of stories that they can be delivered within an iteration. For task allocation, during the task planning stage, the developers break down stories into development tasks. Should take, say, on the order of 4 to 16 hours. All of the tasks that must be completed to implement it. All the stories in that iterations are listed, and the individual developers then sign up for the specific tasks they will implement. The benefits are this: the whole team gets an overview of the task and complete an iteration. The developers have a sense of ownership in these tasks, and is likely to motivate them to complete the task. For software delivery, a software increment is always delivered at the end of each project iteration. If the feature to be included in the increment cannot be completed in the time allowed, the scope of the work is reduced. The delivery schedule is never extended. For Agile planning difficulties, Agile planning is reliant on customer involvement and availability. This can be difficult to arrange as customers representatives sometimes have to prioritize their work. Furthermore, some customers may be more familiar with traditional project plans and find it difficult to engage in an Agile planning process. For the applicability of Agile planning works well for small, stable teams. However, when teams get large or geographically distributed, or when team members change frequently, it is practically impossible for everyone to be involved in a collaborative planning. Okay, well, let's talk about estimation techniques. Organizations need to make software efforts and cost estimates. There are two types of techniques. There's the experience-based technique, where the estimate of future work is based on the manager's experience of past projects. And there could be algorithmic cost modeling, where a formula is used to compute the project effort based on estimates of product attributes. And so those are the two methods. And you can see the estimation uncertainty as you go towards delivery. And of course, as you get towards delivery, the estimate will be less, but in the very beginning, it could be fairly high. For experience-based approaches, experience-based techniques rely on judgment based on experience of past projects. Typically, you identify the deliverables to be produced by a project and the different software components. You document these in a spreadsheet, and it usually helps to get a group of people involved in the effort estimation to ask each team member of the group to explain their estimate. So what are problems with the experience-based approach? The difficulty is in a new software project, there may not be much in common with previous projects. Software development changes very quickly, and a project will often use unfamiliar techniques such as web services and other things. If you have not worked with these techniques, your previous experience may not help to estimate the effort required. For algorithmic cost estimates, its cost is estimated as a mathematical function of products, project, and process attributes, as each one of those are considered. The most commonly used product attribute for cost estimation is code size. Most models are similar, but they use different values for these different elements, A, B, and M in the formula shown above. For estimate accuracy, the size of software systems can only be known accurately when it is finished. Several factors influence the final size: reuse of components, programming language, and distribution of the system. As the development process progresses, then the size estimate becomes more accurate. The estimate of the factors contribute to B and M are subjective and vary according to the judgment of the estimator. For the effectiveness of the algorithmic models, they are a systematic way to estimate the efforts required. However, these models are complex and difficult to use. There are many attributes and considerations, considerable scope for uncertainty in estimating their values. This complexity means that the practical application of algorithmic cost modeling has been limited to a relatively small number of large companies. So let's get into a cost model here. And so here, this is an empirical based model on project experience, COCOMO. It's a well documented, it's a long history since 1981. And COCOMO 2 takes into account different approaches to software development, reuse, etc. It incorporates a range of submodels that produce increasingly detailed software estimates. And the submodels are application composition, early design model, reuse model, and post-architectural model. And I'm going to skip this, but this just gives you some more details about the estimation process for this model. So the application composition model, it supports prototyping projects. It's based on standard estimates of developer productivity, takes software tool use into account. And here is a formula, which I won't read. And PM is the effort in person months. NEP is a number of application points, and prod is the productivity. So relatively speaking, still a kind of a simple equation. And so here are some details in terms of the application point productivity. And so you have the developer's experience and capability that's listed. And so it gives you a range, and then there's a point values that can be associated with that for the prod. For an early estimation design model, estimates can be made after the requirements have been agreed based on a standard formula for algorithmic models. And here is the model, the equation. For multipliers, multipliers reflect the capability of developers, the non-functional requirements of familiarity with the developer platform, etc. And here are some various multipliers that are shown. For the reuse model, this takes into account black box code that is reused without change. And there are two versions: black box reuse, where code is not modified, and white box reuse, where the code is modified to a limited amount. For the reuse cost model estimates, in here is an equation for generated code. And so you can have that as a reference that you can be aware of. And we're using these acronyms that we defined before. Here's another reuse model. This is used when the code is to be understood and integrated. Here is for post-architectural levels, you can use the same formulas as the early design models, but with 17 rather than 7 associated multipliers. The code size is estimated as the number of lines of new code to be developed. Estimate of equivalent lines of new code computed using the reuse model, and estimate of the numbers of lines of code that have to be modified according to requirements change. For the exponent term, this depends on 5 scale factors, and they sum anyway, it's just some more details about the exponent term that you can read. I'm just going to speed over this and not focus on this in too much detail, but here are the scale factors and the exponent computation for the post-architectural model. For multipliers, you can have product attributes, computer attributes, personnel attributes, and project attributes. And see, these are all things that can be brought in for the evaluation. Here is the effective cost drivers on effort estimates. And so you can have that as some reference information as well. Here's some more things related to that, the effects of cost drivers. For project duration and staffing, as well as the effort estimation, managers must estimate the calendar time required to complete a project and when staff will be required. And so the COCOMO 2 formula can be used. And here is an estimation of what that would be like. The time required is independent of the number of people working on the project. For staffing requirements, staff requirements can't be computed by dividing the development time by the required schedule. The number of people working on the project varies depending on the phase of the project. The more people who work on the project, the more total effort is usually required. A very rapid buildup of people often correlates with schedule slippage. So just to finish up here, we covered at a high level a lot of information. The price charged for a system does not depend on its estimated development cost and the profit required by a development company. Organizational factors may mean that the price is increased to compensate for increased risk or decrease to gain competitive advantage. Software is offered price to gain a contract, and the functionality of the system is then adjusted to meet the estimated price. Plan-driven development is organized around a complete project plan that defines the project activities, the planned effort, the activity schedule, and who is responsible for each activity. Project scheduling involves the creation of various graphical representation of a part of the project plan. Bar charts which show the activity duration and staffing timelines are the most commonly used schedule representation. Project milestone is a predictable outcome of an activity or set of activities. At each milestone, a formal report of progress should be presented to management. A deliverable is a work product that is delivered to the project customer. The Agile planning game involves the whole team in project planning. This plan is developed incrementally, and if problems arise, it is adjusted so that the software functionality is reduced instead of delaying the delivery of an increment. And to finish up here, estimation techniques for software may be experience-based, where managers judge the effort, or algorithmic, where the effort required is computed from other estimated project parameters. The COCOMO 2 cost model is a mature algorithmic cost model that takes project, product, hardware, and personnel attributes into account when formulating a cost estimate. Okay, that'll end our lecture, and thank you very much.